Okay, so we're going to talk about this dealio that is the law of sines. So, as it says up here, up to this point we've been working exclusively with right triangles to solve with SOHCAHTOA. However, these ratios only extend to right triangles in the sense that we've been using them, but we can extend these beyond right triangles in different ways, and we can use these with any kind of triangle if you know the right formulas and have the right information. So real quick, I'm just going to tell you the law of sines right now. Pretty sweet, pretty easy, very similar to what we've been learning already, and it's just a proportion. So it's going to be the sine of A over side length A is equal to the sine of angle B over side length B, and that's also equal to sine of angle C over the side length C. So that's the law of sines, and I'm going to show you where this comes from real quick. Just so if you don't memorize this, you can at least make sense of how to get there. And you know that this isn't just some random formula that someone came up with. This really is something that's mathematically sound. So when we just think about the sine of A and B, for example, the sine of A, I'll split this up. So here's your law of sines formula. This is going to be where I'm working now. So our sine of A equals the opposite over the hypotenuse, so it's h over b. And the sine of B is equal to the opposite over the hypotenuse, h over a. Right? So if we use our algebra with this, let's multiply sine A times B. So we get B sine A equals h. And let's multiply sine of B times A. So we get A sine B equals h. And from here, if we know that this equals h and this equals h, that's like saying this equals 1 and this equals 1. And if these both equal 1, what do we know about these two things? We know that they're equal, right? So if this equals h and this equals h, we can set these two things equal to each other, like this. And we get the side length B times the sine of angle A is equal to side length A times the sine of angle B. And this last step here is where we're going to find our formula. So what we can do is divide this side by A, divide this side by B. Divide this side by A, which means we have to divide this side by A. Now we're going to divide this side by B, which means we're going to have to divide this side by B. And if we divide this by AB, our B's cancel. If we divide this side by AB, our A's cancel. And so we're left with sine A over A is equal to the sine of B over B. So here's the formula, and here's how we get there, just using our trig functions. So this is pretty neat. It's just ratios like we've been using up until this point. So if you know the angle measures or if you know any of these three things, you can always solve for that fourth thing. And so that brings us to this. The law of sines can be used when we have opposite information. And what that means is just, for example, we would know the measure of angle A and the measure of side length A, because these are opposites, right? This side length isn't touching this angle, so they're opposites. Similarly, if we know the side length of B, or the measure of angle B, and the side length and the side length of B as well, that would be a ratio that we could use to find other ones. So that's the law of sines, and along in this video, I'm just going to write down the law of cosines so that we have multiple things in the same spot. In class, though, I will explain, similarly to how we did with the law of sines, how we can get that law of cosines so that we can make sense of it, because it's a little more difficult. But I'll write that law of cosines down here. So the law of cosines can have three different forms, but it's all the same pattern. So we can solve for side length A, and we can do this by having A squared equals B squared plus C squared minus 2BC, and then times cosine of the opposite angle of this side. So these two letters will always match. There will be a lowercase and an uppercase. So these you can think of as being like the book covers, and you're going to close everything up. So you've got the Pythagorean theorem here, and then you've got minus 2BC and cosine of A, which is the opposite of this side length. So this formula can also look like, for the other letters, we could have B squared equals A squared plus C squared minus 2AC times cosine B. As you can see, we've got our book covers here, and we're going to close everything else in. And then lastly, the same way, we've got C squared equals A squared plus B squared minus 2AB times cosine of C. So here's our law of cosines formula. Like I said, it might be pretty difficult to memorize, but you can think of it as the opposites are at the ends. Now we're going to close the other information up. And so this is usually to solve for either this side length or this angle measure if you're given the other things. So we'll talk more about that in class, talk more about why we end up with this formula and what it can do for us. But hopefully you are following along and you can try out some of the examples down below.